In this presentation, we're going to introduce the general topic of stoichiometry. Stoichiometry is the area of chemistry in which we learn how to relate different substances taking part in chemical reactions to each other. So, for example, if so many grams of this substance react, how many grams of a particular product do we produce? The first thing we want to do is introduce a unit. The unit is something called the mole. The mole is simply going to be a way that we can count atoms or molecules. We can think of the mole as simply being a very large number for expressing numbers of atoms and molecules. This number is often called Avogadro's number. And so 1 mole is equal to 6.022 times 10 to the 23rd. I'm sure if you've taken chemistry before, you've heard of that number. And so, for example, and it's simply a number, like 1 million is a number. So I could say, write the word million in words, and it stands for 10 to the 6th. And that's the way we usually think of it. So, for example, if I say 1 mole of hydrogen atoms, written as H here, that's the same as saying 6.022 times 10 to the 23rd hydrogen atoms. Or if I say 1 mole of CO2, that simply means 6.022 times 10 to the 23rd CO2 molecules. Or to say 2 moles of NO, well then that, again, now I'm talking about counting NO molecules, and it's simply twice Avogadro's number, or 12.044 times 10 to the 23rd. For ionic compounds don't come in molecules, but rather formula units. And so, one formula unit of magnesium chloride consists of 1 magnesium atom and 2 chlorine atoms. And 1 mole of magnesium chloride is simply 6.022 times 10 to the 23rd magnesium chloride formula units. Now, we can use this, the way this is useful to us is that if I know the ratio of a certain number of atoms or molecules in a chemical reaction, so for example, if I know that one water molecule contains 2 hydrogen atoms, then I also know that 2 water molecules contains 4 hydrogen atoms, or going to large numbers, 1 million water molecules contains 2 million hydrogen atoms. So here it's like 2 atoms, or I can carry that to a very large number, to Avogadro's number, and 2 atoms hydrogen in 1 molecule of water implies that there are 2 moles of hydrogen atoms in 1 mole of water. And so wherever I have a ratio of atoms or molecules on the individual molecule level, I can express that same relation for moles. And this is particularly useful in chemical reactions. So 1 molecule of CH4 reacts with 2 molecules of O2. That implies that 1 mole of CH4 reacts with 2 moles of O2. Again, because the mole is simply a way of counting atoms and molecules. Now, why the number 6.022 times 10 to the 23rd? Was that just pulled out of the air? Well, it turns out that if we could have chosen any large number as a convenient counting number for atoms or molecules. It's a very, very large number, almost unimaginably large. But it turns out that when we use that number, that the formula weights that we express in atomic mass units, so we look in the periodic table and we see hydrogen weighs 1.007 atomic mass units. Well, that also implies that hydrogen weighs, 1 mole of hydrogen weighs 1.007 grams. So if we read the if we read the numbers in the periodic table as grams, then those numbers refer to the number of grams in 1 mole. So when we see a formula weight or an atomic weight, a formula weight, we can interpret it as being atomic mass units, or we can interpret it as being grams per mole.